Okay, let's start talking about series circuits. Now, let's do first things first. We're going to use a 24 volt circuit here. It's 24 volts DC, which is reasonably safe to work with. And the safety tip of the day is always check your power before you start to work on the circuit. Okay, so we've got a power supply here, and the meter is set to DC voltage. We've got 110 volts coming in. We have a DC power light on that says the DC is there. So I've got the black probe for the meter hooked up to the negative. So we're going to check to the positive, and sure enough, we get 24 volts, absolute dead even. So that's a good power source we've got there. So let's talk about the series circuit. We're going to use toggle switches in this case. I think I used CR on the demonstration drawings, but basically it's exactly the same thing. A control relay closes and opens, and a toggle switch closes and opens, so you can kind of see what's going on. So the red means there's some voltage there, the black means it's just a conductor. Normally open switch, number 1, number 2, number 3, number 4. Let's number those. SW1, SW2, SW3, SW4. So there's switches 1 through 4, and this is LT1, and we are using a LED bulb for this case, and it is rated for 24 volts DC. Now, the important thing to remember about a series circuit is that the first one and the second one and the third one and the fourth one must be on before we receive power to our output. Because if you look, the power comes in here. This is the hot, this is the plus, and it has 24 volts potential on it. And it goes into this first switch. It goes through that switch. As you can see, in this case, that switch is open. So no power gets to the other side. Let's check and see if that's true. We do have power on the incoming side of the switch. We do not have power on the outgoing side of the switch. And again, I'm reading potential between this point and the return line, which is, in this case, is the negative. So we know now that we have power up to this point. Now, if we turn this switch on, it will have power here. It will also have power on the outgoing side, and the incoming side to the second switch will have power. The outgoing side has no power, as you can see. So, if I flip this switch on, that allows power to come through the first switch. We got the first one. We've got the output on the second one. We've got the input on the second one. We've got the output on the second one. We've got the input on the third one, but because it's not turned on yet, we do not have any power on the outgoing side. So we have 0. So let's switch that one on. So now we have power coming to the input as well as the output, and we also have power on the input to the fourth one. So let's switch it on, and we do have power going to the output, and the light is lit. Now let's talk about terminology. On a series circuit, when we're describing it, we say if. If means the beginning of a rung. It's the beginning of a circuit. So if you say if to someone, that means that's the beginning of the circuit. So if SW1 is on, and SW2 is on, and SW3 and SW4, then then means we're at the end of the control circuit. That means that when this is lit, that the load has received power. So if SW1 and SW2 and SW3 and SW4, then we get LT1. So if you turn any one of these off, the power source. So in this case, if SW1 and not SW2, because it is not on, and SW3 and SW4, then we have not LT1. So the terms are if for the beginning, and is for each of the things in the series, then means you're at the end of that series and you're about to go to the load. So if I flip this back on, as you can see, the light comes back on, which means we have power from the source all the way down to the input to the load. The output to the load, the voltage is used up or dropped. The correct term is dropped, voltage drop. So we've dropped the voltage here, so we have 0 potential on the negative side. We have 24 volts potential here, so the meter reads between the two and says we have a 24 volt potential difference. And that's how this circuit works. Let's go through it in a different way. Let's actually change the drawing to match what we've got. So let's turn all of them back off. And if we turn the first circuit on, it delivers power to the incoming side of the second switch. And this is an AND. If, and, then. So, if we turn on the first switch, it delivers power to the incoming side of the second switch. So now, if we close the second switch, oops. So if we close the second switch, it will deliver power to the incoming side of the third switch. Okay. So now we have turned on the first switch. It is in the closed position. Now we will close the second one. And if we look at the meter, we will see that now we have power incoming on switch 1, also outgoing on switch 1, and incoming on switch 2. And if I turn switch 2 on, then I have power on the outgoing of switch 2, and I have power on the incoming of switch 3. Going out of switch 3, however, I have 0. So the power is only going through the first switch and the second switch, and it is at the third switch, but it has not gone through it yet. So let's turn on the third switch. And we turn that on. Now we have power leaving the third switch and onto the input of switch 4, but not going out to the load. So far, we've closed switch 1, we've closed switch 2, we've closed switch 3, and we have power from the source all the way down to the input to the fourth switch. Now, let's flip on the fourth switch. And if we turn on the fourth switch, Power goes down, and guess what? The light lights up. And if we want to prove that, we will close this fourth switch, and bada bing, there you go. The light lights. So, the important things to remember, in a series, it must go through one device before it can go to the next. And the terminology is if SW1 and SW2 and SW3 and SW4, then the load, or the light in this case, lights. And that's the explanation of the series circuit. Okay, now let's take a look at a parallel circuit. We're going to do the same thing. This is the same power supply, and we're going to check the voltage. And as you can see, we've got a good 24 volt signal there. It's perfect. So this is the minus, this is the plus, and again we have 24 volts there. So now this is a parallel circuit, and parallel is different in many ways to a series circuit. So as you can see, the power comes in, the plus comes in. Let's change that to red so it's clearer. Okay, so as you can see, the power comes in, the plus, so the voltage comes up to each switch, and it's hot all the way up to each switch. So we have 24 volts coming to the incoming side of every one of these. So let's get the meter going again. It's shut down. Okay, so we've got 24 volts coming into the first one, and 0 going out. Well, 5 volts, but it's leakage. So anyway, we have 24 volts going to the input on the second one, and we have 5 volts coming out. We have 24 volts on the third one going in, and nothing going out except the 5 volts, which is leakage through the LED. We have 24 volts coming into the last one, and pretty much 0 going out. So if we flip any one of these switches on, let's flip switch 2, you can see the light does come on with one switch. Now why is that? Because when I close this switch right here, it allows power to come through, and it also allows power to go to the first switch on that side. So now this entire side is hot. So in series, all of the switches must be on. In parallel, any one of the switches must be on in order to make the circuit complete. Because at this point we have power coming in from the source here, it's going to here, it's going through switch 2 and up to light 1. Now, again, we will start with if here, and we will do then here. But in this case, it's switch 1 or switch 2 or switch 3 or switch 4. So or is the correct terminology for parallel. So series is and, because this one and this one and this one and this one must be on before you receive power to the output side. So if in a parallel circuit any one of these may be turned on. Now let's prove that. Let's turn this one back off, and you can see the light goes out. Let's try switch 3. Ha ha! It also turns the light on. Switch 1 also turns the light on. Switch 4 also turns the light on. If I turn all of them on, then the light is still on, because then the power is going through all 4 switches. So if is the beginning of the circuit, and is series or is parallel, and then means out on the output side of things to the load. In this case, it's our light. If means we're starting the circuit. If it's through a series circuit, we say and, because switch 1 and switch 2 and switch 3 and switch 4 must all be on before we get power to the load. In parallel, we still use if, only we say if switch 1 or switch 2 or switch 3 or switch 4 are on, then we receive power to the load, as you can clearly see. So if I turn these off, switch 1's off, switch 2's off, switch 3's off, they're all off, and then if I turn switch 4 off, then the light goes out again. So that's pretty much the explanation of a parallel circuit.